Hello and welcome to the Yokogawa workshop this morning, at least this morning in the US. And we have with us today Eugene Spiropoulos of Yokogawa. He's a global systems business and consulting leader with them. And he will be covering the topic of defining optimal industrial enterprise architectures. And with that, let's go ahead and start the presentation.
Hi everyone, good afternoon and welcome to the ARC Forum 2021. My name is Eugene Spiropoulos. I'm a technology evangelist for Yokogawa, and today I will be discussing defining optimal enterprise architecture for process industries. Thank you very much for your time today. Agenda-wise, this presentation will cover a number of things. It'll cover generally what the challenges are about looking at the big picture of an enterprise for digital transformation. It'll cover the key to doing that, which is establishing context across different areas of the organization. It'll establish the tools we have for doing that, kind of what I call the ghost in the machine, essentially the platform or software or capabilities for integrating multiple different functions together to achieve this context. And we'll look a little bit at some of Yokogawa's tools for doing that. This presentation more deals with the strategies for doing that, not the technologies themselves. And we would finally look at what this means for the future. Essentially, putting all this stuff together, where is that taking us? And I think hopefully this will be a very interesting discussion. So to set the stage a little bit, we are facing a new reality. I think about a year plus a year and a half ago, the question on most people's lips was, what is digital transformation? What can it do for me? I think after 1 year of COVID-19, I think everybody knows what digital transformation is and what it can do for them or their organizations. And the challenge now is establishing how to go about it. And that brings us to the challenge I call the 6 wise consultants and the elephant's digital twin. And the idea here is that people have knowledge across their particular area of subject matter expertise. And 6 wise men, each with knowledge of a part of the elephant, if you guys know the story, can accurately describe the tusk or the ear or the side of the elephant, and they will be accurate and right within their area of knowledge or their area of subject matter expertise. But to describe the elephant, you need to put all of these together. And this is the same thing with the enterprise. The enterprise, so to speak, is the elephant. It has a number of moving parts, and sometimes they can be quite distinct, quite different. But it's only by putting them together and establishing the context between them that you can really define what is the best path forward for digital transformation for your enterprise. And I'd like to discuss a few strategies for doing this. Well, in a nutshell, or rather in a cake, the idea is to sort of bind all of these together with context. And as we're going to look at in subsequent slides, this context is knowledge and the digital twin, and how we can leverage knowledge out of the digital twin in context with all areas of the business. So we're looking now at essentially 5 pillars, and these are assets, operations, people, and the enterprise. And running through all of this is the digital twin. Now, defining the digital twin as a digital representation of a function or an asset is not too far off, but we kind of want to broadly extend that to multiple parts of the organization, particularly where we see context. And we're going to start out with the assets. So assets can define many things in an organization or in an industry. And being as broad as possible, but still keeping the strategy together, let's do a deep dive into the micro components of these assets. And we're not going to go into all of them overall for process industries. But we kind of want to establish a strategy together with different stakeholders in the organization for the value we would get out of establishing digital twin and context out of each of these micro components. And they could be analytical, they could be sensors, they could be infrastructure, they could be equipment, compressors, they could be anything. They could be people. The idea is, how can we faithfully represent digitally each of these functions so that we can manage its effectiveness over its life cycle, but also leverage value from that digital twin in other areas? And assets is a big part, but there are other parts as well. And the next one we will talk about is operations. And operations, like assets, means many things. We typically in process industry start out with the actual project delivery itself and then move on with the life cycle from there. And that's kind of highlighted in what we see over here, with the left side being standards, automation, going all the way to the right, which is the digital twin and data-driven context. And the idea is, for each of these pillars of operations, how can we represent their function with the digital twin, and how can we include that in the context of everything else? Moving from operations to the digital twin, we start to see how all of this comes together. And here we're really looking at a map for value across digital assets. And going from the left to the right, for different consultants or different subject matter experts, each of these will ring a bell. Predictive plant maintenance, AI-driven analytics, but also we get in the middle towards more of the high fidelity process digital twin, whether it's steady state, whether it's dynamic, and then we start leveraging that off into other value. The digital twin of operating procedures. How can we include that with the high fidelity digital twin? What value do we get from doing that? How can we extend out this high fidelity digital twin with some of the asset modeling we've already done to build out energy model digital twins? How can we interface that with the business for supply chain model digital twins? And how can we tie all of that together into a broad overriding context? Now we want to look at probably what's the most important part of establishing this enterprise architecture, but very unfortunately, it's also the part that's very much underlooked, and that is people. People are also assets, people are operations, and people need to be considered in this overall value like everything else. I think one of the core benefits we derive from this scale, enterprise scale, digital twin architecture is improving and maximizing the efficiency of people. It also, as we would see later on down the line, starts to play into safety, compliance, and people sustainability. But people are a core part of this, and very often they are underlooked because it's very often just about the software or just about the technology. And that is very often why these enterprise scale digital transformation projects fail. So what do we do with people? What can we do with people? Well, the idea is, broadly speaking, on the left side, we want to build people's knowledge. And this can be in the form of training programs. It can be in the form of different sorts of expertise building programs on different areas pertinent to their role or to their function. And this can take multiple different shapes. However, on the right side, we have knowledge retention. How do we keep this knowledge with the people? How do we ensure that the people are taking advantage and utilizing this knowledge? How can we map this knowledge, the digital twin of expertise? How can we bring that to bear in operational behavior? And how can we keep that in the organization for posterity? And this can sometimes be a really difficult thing to do. But by leveraging technologies that are available and by leveraging the expertise and the best practices of your operations, it is possible to do that and deliver a strategy for keeping that knowledge within the business. So moving on from people, we finally get to the top of this, which is the enterprise transformation. And so far, we've built a framework from assets to operations to people, all mapped together in the digital twin. Now, how can we map that up into different business functions? And that is where a lot of the role of the data integration partner comes in. And that is becoming more and more a function that most organizations are beginning to invest within their people. There is a lot more data science in process industries and industrial automation today than there was 5 years ago, and it's not going to let up. Taking advantage of data is now within reach. Essentially, with the technologies and platforms, we've been collecting data for years. And most organizations really use about 5% of the data that they have collected. We are getting to a point now where we can greatly, significantly increase the power and the value we get from that data. Mapping that into the business, but with the context of the framework that is established, is an extremely powerful thing that bears value right away, but has a chance to bear a lot more value in the long term. And that kind of takes us to where all of this is going. And it's the integration of platforms, the integration of people, the integration of functions. So this presentation is really about the strategy for putting this together, not so much about the technology. In Yokogawa's case, we would use the collaborative information server. And that's a system-based application that ties all operations in together. It also ties multiple systems in together and multiple functions and roles. And I'll use that as an example of how a platform or technology can be used to derive this value. But it's at the end of the day, technology will not on its own do it for you. It really takes a fair amount of forethought, and it really takes this context in between different functions. Now, establishing that core context for the enterprise and then scaling that out across multiple different sites. So now you standardize the data functions and the data structures across the enterprise. And this is where value really starts to come in for certain types of industries. As we do more and more in the broad geographical based offshores and renewable energy, wind farms, solar farms, integrating multiple different types of energy generation, for example, together with energy transmission and consumption, and trying to optimize all that together. That's a really great use case of this sort of platform. Operations, maintenance, business people, process people, all leveraging the same tools, the same technologies, but most importantly, the same context. This gives for industries today, it's a much more collaborative or cost-effective way to achieve what has been difficult for many years, which is getting those 6 consultants to speak together with the same language. And that is the opportunity that's available today for many industries by leveraging the context of different digital twins together. So where is this going and where is this taking us? Well, most industries have an end goal in mind. And at the end of the day, it is really about people sustainability. It's about ensuring compliance, safety, profitability, but it's also about ensuring a benefit to society overall. This journey to industrial autonomy, industrial autonomy essentially means all of these different functions and contexts that we spoke about can work together without the requirements of a, a person in between taking action, but more importantly, usually looking for what action to take. And that impacts very much efficiency. It impacts many, many things overall in the end goals of an enterprise or the end goals of a company. So being able to bring these different levels of automation and people together into one comprehensive function or comprehensive set of functions is really the direction many industries are trying to take. Over here at Yokogawa, we've put together a number of stages that we see as companies begin to adopt these capabilities and grow towards this overall end goal. Semi-automated, automated, semi-autonomous. Between automated and semi-autonomous is typically where you would find most high-performing companies today. As we start to get towards the aspirational, autonomous orchestration, autonomous operations, and then finally industrial autonomy, this is going to take the leveraging of all of these tools, but also the leveraging of the context in order to achieve this. So where is this journey going to take us? Or in a nutshell, what's going to change in IA or in society over the next few years with this ability to leverage more data and provide context to multiple functions? Well, I think it's really a time for change. And the IT-OT convergence was really just the beginning, because now there's robots and there's all sorts of other technologies, artificial intelligence, that come together and provide context for each other. What we are looking at now is a transformation of production and production industries. And yes, it has been accelerated by eye-opening things that have happened in recent years. But it's also accelerated by the capability of data and technology, and accelerated by the common knowledge or the common capability of data science to run across all of these levels of expertise. So we can leverage via data and information, chemical engineering expertise with automation, electrical, computer science, artificial intelligence, all towards a common goal. And the organizations that build these structures or map together the context between these structures in order to leverage for their end goals and for society's end goals are the organizations that are going to have the edge in the upcoming future. How does Yokogawa help? Well, consultants like myself provide expertise for this context, but we of course also provide data integration and technology platforms to bring all of this together, like I described in previous slides. But it's not something that we do alone. It has to be done in context with other providers and, most importantly, with our customers and partners themselves. But it has to be done in such a way that stakeholders across the organization can leverage their knowledge into the building of the context. And then the sky's the limit. Leveraging the right context with the right technology and the right integrated models to leverage the best in people and the best in artificial intelligence is going to be the best in class way of executing a life cycle of the enterprise. I hope this has been useful. I really look forward to any questions and detailed questions or inquiries that you guys have. It's a great topic and I've kept it at a very high level, but we can really dig so much deeper into this. I hope you guys have enjoyed it, and I really wish you a wonderful day and a happy 2021. Thank you very much for your time.
Thank you, Eugene. With that, we want to get into a question and answer period with this, where you can use the Q&A at the bottom of the screen. You'll see in the toolbar, there's a Q&A. We prefer you not use the chat function. And then I can relay those questions to Eugene. We can get an answer from him. And that would be awesome. We also have Kevin Finnan on the line, who's also with Yokogawa. And if he said that if Eugene can't answer it, he probably can't either, but he's going to try. So um, first question is, can we have the presentation? I believe that is going to be available. If not, definitely the video is going to be available afterwards, because this is recorded. Let's see. I don't see any other questions. There's a couple in there. Let's see. There you go. Oh, here we go. What is the main, I guess it's for either one of you, Eugene probably, Michael, oh, I'm not going to be able to say his last name. I'm going to say it's Zanzu. What is the main drive for autonomous systems?
The main drive for autonomous systems? Well, there's quite a few. But I think, like I mentioned in the presentation, it does come very much down to people. And we are seeing this sort of change in the world and the way people work and the way people can work. And I think that's been eye-opening in a number of ways, but that hasn't been the only driver. I think there's a factor of efficiency. Companies want to be more efficient, particularly in manufacturing, in process industries as well. So that efficiency drives cost efficiency as well. So that increases profitability. So all of those are tangible factors, but the real overriding one has to do with people and what I call people sustainability. And that is the ability to sort of empower people from wherever they are to be able to focus their time, their efforts, and their capabilities on the things that add the most value from a people point of view. And so that's, being able to sort of remove, that equation or that doubt and put as much in the hands of the system as possible to be executed, while freeing up people to be able to do the things that people do best for profitability, for efficiency. I think that's one of the biggest drivers that we have for this sort of autonomous operation.
Okay. Got a question here from Heidi. It says, how can we work with a transition workforce to be prepared? And then there's a second question. How do you see university and other education systems preparing a new engineer? Is it more data science skills or engineering skills or other types of skills? What do you see?
I think both of those questions are kind of similar. I'll answer them backward. The first is, how do universities better prepare engineers for the engineering world? To be honest, that's really a bit of a challenge. And I think that most engineers, after graduating school, have gotten out into the workforce and gone, oh my goodness, this is, it's not all fluid dynamics, so to speak, because there's, so I think that's, for universities today preparing people, there's a lot more of the collaboration side that I think is very important. Solving problems together, joint projects, not just in a university team, but across the board. And with regard to knowledge, our big sort of trick of the 21st century is data and information. So data science is very important. Being able to being able to frame a problem properly, and then being able to utilize data to solve that problem, in and around the engineering knowledge and the engineering tool sets, combined with a more collaborative approach to engineers working together, maybe across universities. I think that that's probably that's probably the shape of engineering training for the future. But that's my guess, and that's the stuff I would have liked to have when I was coming out of school.
Right. Well, it kind of goes back to when I got out of college a while ago. I graduated electrical engineering, and they pulled me into process control. I didn't know anything about chemicals, but I knew everything about the computers, right? And so we're in a very similar situation where you've got to know about the physical, and you've got to know a little bit about data science, and you got a little bit about IT you've got to know. You know, there's a whole bunch of things that a degree isn't really targeted towards. So you've got to look at other ways of augmenting that knowledge set. So that's a really good question.
It's a great one. And you start to think about things like sort of these sorts of hybrid sort of degrees and hybrid functions where you can, if it's possible, instead of going into a straight sort of route for getting a degree, you have more options to mix and match some of these other functions and tools that you talked about into preparing yourself, or the university preparing you for what it is you're actually going to face in the workforce, or for what it is you want to do when you get out into the workforce. So I think things are becoming more flexible now, and I think that's a good thing.
Yeah, and it may be a situation where manufacturers need to start getting more involved with universities to help them set curriculum to address this.
Absolutely.
Yeah. Here's one that is related. Sergio is asking, how do you think the process of knowledge transmission and training should be developed in this area?
That is a big challenge. And that is where the digital twin, or the concept of the digital twin, that's where that's where it has a hard time, so to speak, with people's knowledge. But you want to capture people's knowledge as part of the digital twin, in those pillars that I mentioned. It's very important because it gives you the context on what is used, what is of value and what is not of value, and it also gives you that ability to maintain that value as people move within the organization or in and out of the organization. So knowledge engineering, being able to both build knowledge and retain knowledge, is huge. And there's tools for doing that, but I think organizations need to probably start looking at the program function for particular roles or particular types of roles. So rather than bringing somebody in to work and grow in a particular function, it's work and grow, but also learn in these stages across the organization or across the time they spend in the organization. And that's to build knowledge and standardization. And then how do we retain that? There's the people factors, things like caravan training, ensuring that people who know train others and build that knowledge within the organization. But how can we digitize that? How can we make that digital? And there's application, there's methods of doing that depending. And I think bringing all that together is very important. For example, I'm trying to not talk about technologies and so on, but I'm going to have to here. In the case of Yokogawa, we utilize something called the exapilot, and that captures the knowledge of experienced operators, sequences it, makes it available to other operators, makes it available to other systems. And that's just an example, and that's for a particular type of operational knowledge. There's a very, very broad spectrum of knowledge that maybe that may not be particularly suited for, but but the concept is the same: to be able to capture that knowledge, sequence that knowledge, improve that knowledge, and share that knowledge in a digital platform. So that's some of the things that organizations can do to sort of continue to build that knowledge level within the organization and ensure that it doesn't leave, which is a huge challenge they face today.
Okay, I'm going to switch. There's a set of questions that have come in about the autonomous operations, and so let me switch to some of those. So Sharul Rashid asks, is there any international standards terminology, based on codes or standards or whatever, around autonomous operations that they can refer to or reference?
Around this point in time, and Kevin, let me know if you have other information. Around this point in time, standards around autonomous automation, I think that's fairly early at this point in time. I think they are coming, but I do think that right now what we have, if it helps, is the standards for the pieces that will come together and become autonomous operation. So we do have some of those standards showing up now, particularly for things like assets and so on. But bringing all that together into something autonomous, there are roadmaps, but I don't think that they are standards at this point in time.
Yeah, I totally agree with Eugene. Yeah, there aren't standards for autonomous operations, but all those are really around architectures. And, there was another question, Eugene, about how this vision relates to open architecture like OPAS and NAMR. Those are really the reigning standards right now.
Yes. So thanks for pointing that out, Kevin. So there are those standards for NAMR and open process automation, and these are really big seismic shifts in process operations and process automation. Those are the pieces, those are, like I mentioned, those are sort of the pieces that will fit together to form an autonomous standard later on down the line, because they are taking things that were not necessarily digital standards before, that were kind of left to vendors or left to organizations, and trying to make that kind of common across the board. And that will lead to stronger standards a little bit higher up when combined with some of the other standards that we see for things like assets and so on. So we can see the path down the line, we can see the roadmap, but all of them will need to come together as we walk the walk.
Mm-hmm.
Yeah, in fact, Eugene, another example is that I think that'll require standards for entities such as digital twins. So when you look at digital twin standardization in that regards, it's very, very early on in the process.
Because of that, it's a digital twin accurate for each context. Now, bringing all that context together is, that is the, I think that's the journey that we're on.
Okay. There's another question related to autonomous systems. It says from Michael Zandu. At the end of this, I'll probably figure out how to pronounce his last name. No offense. Is there a balance between the drive for autonomous systems and sustainability?
So a balance, they go hand in hand, I think. So so not so much as seeing it as a compromise, one or the other, but seeing it as, they walk that road together. So autonomous systems and the drive for autonomous systems is it's driven by the drive for sustainability. So one sort of leads to the other, and I think that it should start from sustainability. It should start from, I guess, from something that is good for people, good for the environment, good for society, good for business, because all these things are very, very closely linked. And autonomous kind of develops to achieve that, would be the way. So I think they work hand in hand.
Fair enough. There's a lot of great questions here. I don't know. We got plenty of time, but we'll just work through them. I think this one here from Bruce Marvin is a really good one. It says, what kind of pushback did you receive both from high-level personnel and lower-level personnel when you roll out a project of this nature, and how did you get them to buy in?
Well, so you kind of don't want to just roll out a project of this nature. Mm-hmm. You want to get that buy-in really early. So this sort of enterprise plan, first of all, it's very phased out. You really want to ensure that each step or each milestone of executing this is building a solid foundation for the next step. So first of all, when you start out with looking at each of those pillars that I mentioned, and each of those pillars had sub-pillars, no one person is really a master of all that knowledge, not on the consulting side and not on the customer side. So it needs to be sort of broken up into each of these subject matter areas, into each of these domains. And the stakeholders on the customer side need to have as much input as possible into building up each of those blocks that make those pillars. So at the end of the day, you're not sort of, when you reach a milestone or even the end of the process, you're not rolling something out that's a surprise. Oh, this is how we're doing it now. It's really more, I'm glad that this is now the process. I'm glad that the best practice is now the process. So you're sort of capturing best practices across the board, first on each of these bricks, and then you build those up over the pillars. And on each of these areas, you get the input from the people who know what it is they're doing or should know what it is that they're doing. You find out how that can be improved. You find out how that can be made digital and how that context can apply. And you sort of build up from there. And that way, the organization sees, the map from where they are today to where they're going to be in future, and you get as many people on board as possible. It's not possible always to get everybody on board, but that's where the consulting activity comes in, to ensure that at least as you move forward with each step, it is the right step forward, and you're building up into this overall context, this overall digital context.
Do you see any common objections to this? In other words, just certain objections come up all the time.
Well, yes, there's always really an objection when you cross expertise or cross business domains. There just is. If you're looking at best practices in maintenance, and then you're looking at best practices in, say, operation execution for control, sometimes both sides may not agree, but they need to be very, very much on the same page in order to maximize your reliability and your uptime, and also your profitability and the way you run. So because of this sort of 6 wise consultants and the elephant's digital twin, the guys who think it's a tusk are definitely going to argue with the guys who think it's an ear. So trying to ensure that, well, it is a tusk, but the tusk feeds into this overall big picture and make sure that everybody is at least, if not on the same page, but in the same book. That's how you kind of get over those objections. I hope that was reasonable and was clear and made sense. Please let me know.
Okay. I got some questions that are more pertinent or more specific to the CI server. So maybe we should go over a couple of those because this is your workshop. So Peter Reynolds says autonomous plants and the use of technology such as CI server could present higher complexity in managing technology. Do you see technologies becoming easier to manage through system automation borrowed from IT or systems such as system orchestration?
It could easily go either way.
Yeah.
It could easily go either way. I mean, if it's done, and that's the point of I guess this whole workshop, is to try to make sure it goes one way and not the other. Mm-hmm. And I guess the crux of this workshop is get as much input as possible into building up your strategy. Mm-hmm. And if you do that, then it does become easier to maintain. But if the approach is not cohesive, not in context, if the approach is a number of different separate functions with a number of different separate vendors who are not speaking to each other, and within the organization itself, those are they're managed by silos within the organization. That's how things become more difficult to manage. That's how things become more expensive. And that's how a lot of these things eventually don't, provide the value that were promised. So the key thing is ensuring that people are on the same page and understand the overall context. And that will ensure, or that will guide, making sure that that autonomy and that the road towards autonomy brings value and efficiency each step of the way. I think.
Okay. Kathleen Glasser is asking, do you have any recommendations for first steps that can be realized quickly? Some quick wins, so to speak.
Yes. So it's difficult for me to turn back towards the slide, but the slides themselves, they were kind of arranged in sort of a quick win format. Because if you did look at, in the slides, if you look at something like assets, for example, on the left side are the more traditional technologies. On the right side are the more data-driven technologies. Going for the data-driven technologies without sorting out the more traditional technologies doesn't really work. So you sort of have to build your foundation. If you're, for example, going to find a way to utilize quality data better and faster in order to have a more consistent product or a faster product or a tighter batch, whatever the outcome, it's very important to ensure that your analyzers are good, for example. Otherwise, your data is not going to be great. It's very important to start looking at how, what work people do before execution, what work people do after execution. So for low-hanging fruit, it really starts there at the lower hanging behavior. And if those are brought, if those are tightened and properly digitized and improved, then the next step becomes better. And then the next step becomes better. So for low-hanging fruit, I always look towards the base operations. First of all, how are people doing things? How are people executing things? And what are the gaps and the blind spots? And filling in the gaps and the blind spots, first of all, will build out your foundation for your road to autonomous operation.
Okay. Yeah, that tends to be the harder thing to justify because I filled in a gap, but I haven't realized a gain. I've built a foundation.
But if you filled in the gap, you will realize a gain.
Right.
That's
eventually, yeah.
And sometimes almost immediately, so
okay.
If you look at something like, analyzers is it's a cheap example because if you analyze a bad, you've got a problem. You've got a problem there, but if I take something that's not such a clear example, say for example, let's look at how people manage a particular unit procedure, for example. And if there's a number of people doing it a number of different ways, then even just from that fact alone, you now have variability. Variability is not going to, variability is going to be an efficiency challenge. Mm-hmm. So that's my daughter. So variability is always going to be an efficiency challenge. That's something that's a lot of us are trying to address today. So that kind of threw me off a little bit. but that is so I think for low-hanging fruits and for things that we can address, first of all, that is an important thing. Great.
So Syed Ahmed has this question. I think there's a lot of people in this boat. And he was saying that the return on investment he's had hasn't been really realized on digital twins, and because of the complexity of the systems. And his question is, do you envision this to change in the near future, where it's much easier to realize a return on the investment for a digital twin?
Yes, I think we're seeing that today. And I think that a challenge on the digital twin and not seeing the return on the investment on the digital twin, traditionally, there's been a number of reasons for that. And one of them is that one of the big ones is the maintainability of the digital twin. So a lot of times people make this kind of very fair capital outlay in developing a digital twin. Excuse me, sweetie, I'll be right there. And then it takes a little bit of time over time, the digital twin can drift, the digital assets can drift. New things are added, changes are made to operations and so on. And because of that, the value that they got initially over time is no longer realized. And that has been a big thing for many customers, many industries and organizations that have invested in something like a high fidelity process simulation, for example. So that's one big reason why organizations don't realize the value of the digital twin. The other big reason is the context as well. Making that capital outlay for the digital twin, but not understanding that the context is really where you're going to get the value. I mentioned that digital twins can sort of sit in these silos. And in these silos of particular expertise, there is a certain amount of value that can be derived. But there is a huge amount of value waiting that can be derived from other things, that can be derived from extending the context of that digital twin out into other areas.
Okay, we got a question from
James.
James.
Really quickly, though, that sorry, Mark. Let me just add quickly. Some of the ones that I personally seen with some problems, they required a ton of data. A lot of the digital twins require a very large amount of data to begin with, and if you really lack that sort of data, that could really get it started off on the wrong foot, if you will. Now, the ones that we've been working with, Yokogawa, KBC, they've been highly successful, but that's because we made sure that we had all the data that we needed from the get-go, from the start. But one thing that's happening right now is that you could use artificial intelligence and machine learning to simplify the calibration of the digital twin up front. So you don't need as much high quality information, or data, I should say data at that point up front as you used to. So I think that's one thing that might maybe shortcut the calibration process and get a quicker payback.
I think that, this question is such a good question because it really has a lot of things in. And for example, so we talked about sort of building up this foundation and adding value, and actually extending out the context of the digital twin both increases the value that you get from it, but it also helps make it easier to maintain. Because if you think about, say, a process digital twin, that sits in an organization within a certain knowledge base. So if, for example, there's changes made to sensor technologies, that knowledge base that is maintaining or utilizing the digital twin within the customer organization is not necessarily, does not necessarily update those changes in sensor technologies. So that's where you start to have this drift. But if you have a digital twin that's being leveraged for process engineering, being leveraged for control, and being leveraged for field side as well, then the people in the field are also leveraging that technology. So if there's changes on that level, that's now reflected in the digital twin. So there is this across the board increase in value, but then there's also this across the board increase in maintainability, because now there's essentially, if you go back to the presentation, there's essentially more people kind of invested in this, utilizing this, and it's now also a platform for knowledge retention as well as training people. So
that's a great point.
Yeah. Hey, Mark, if we had if we had a little bit more time, I just might add that one of the biggest issues, Eugene's talking about the maintainability of the system, because now with all the sensors, with the IoT technology, you just have tons and tons and tons of data coming into the system. And that really puts a focus on the validation process. And that's actually a really good application for artificial intelligence and machine learning. So that'll really help out with the data validation process and keep the quality of the data very high, which, like Eugene says, you need for the maintainability.
Yeah, we have a question here that was asking about what percentage of artificial intelligent models would be used as compared to first principle models for digital twins and automation. And it seems to me like you guys are saying it's a mix of both, and it's going to depend on your application, really.
That is correct. I would say that is correct. I would give a little bit of maybe a clarification or maybe a caveat there, because artificial intelligence can be used in a number of ways. It can be used to make sense of your digital twin. It can be used in this, it can be used for a number of reasons, but it can also be used to help maintain your digital twin. And that's maybe the low hanging fruit value. It's ensuring that you've got some AI that's taking the heavy lifting in ensuring that the digital twin stays up to date. And I think for people who've mentioned or asked earlier on, I didn't realize the value from my investment in the digital twin. That's something to think about.
So, kind of switching gears, we talked about your presentation. The title's about architecture. And so one of the questions we got was, do you see digital transformation replacing the Purdue model? If so, with what? And we get this question a lot at ARC, so I'm interested in seeing what you say.
A number of years ago, I wrote an article on that, actually, on is it time to update the Purdue model in ISA 95? And and the reason, for writing that article was kind of seeing this advent of IIoT and artificial intelligence on the cusp of the industry at the time. It was a number of years ago. And so from a infrastructure architecture point of view, things have changed. The level 1, level 2, level 3, level 4 structure. And I usually relate that to cooking. So
must be hungry.
Yeah. Level 1, level 1's your pots and your thermometers and all that stuff, and your level 2 is how you control. It's your stove, your cooking, your stirring. Level 3 is your recipe, and level 4 is your guest list. It's roughly along those lines, anyway. And and idea there, if you map that out, if you look at it that way, then things may not change. So from an infrastructure perspective, they do. So in that sense, ISA 95 and the Purdue model may not represent the infrastructure in process facilities in the near future. But with regard to the functional side of it, what is the objective of each level, they would still remain. So right. I think it is something, I guess, at that point, a philosophical discussion.
Okay, let's see what else we have. There's a question that's very specific to the CI server, and it should be a quick one to answer. It says, how is the collaborative information server different from the conventional DCS, hardware-wise, software-wise? I think that's a pretty easy.
Yeah, it's a fair one, and in a number of ways. I mean, the idea of the collaborative information server is to kind of open that out a bit. DCSs have always been fairly closed technologies for a number of reasons. Some of them good, but some of them bad. And the idea is to be able to leverage technologies today to ensure that more people can work together. And it sort of breaks down those siloed vertical domains where this is DCS technology and this is the information management technology, the Purdue model we were just talking about, and now ensures that an organization can deal with the same context. And the DCS was not great for context across the organization, but technologies like the CI server are great for context across the organization. The other factor there is the CI server, and this is not just with Yokogawa Technologies, this is across the board, but the CI server starts to serve as the gateway to the future. Being able to sort of have one foot within traditional automation and the other foot leading the way towards IIoT type infrastructures, autonomous type infrastructures, and so on, and be able to have an organization leverage today and tomorrow which aspect of that technology is right for the right function, and also handle this shift into the future. CI server is very, I think it's very well placed and very timely as a technology to provide that.
Okay, probably have time for one, maybe two more. Let's go to this one. Based on your real experience in the field with end users, please share what challenges of digital transformation you've experienced, and how does Yokogawa take a role to support the end user taking these giant leaps in pursuing the transformation?
Thank you very much. So that's a really big one. That's a fairly the challenges that we've faced, they've been broad. They've been across the board in many things, and I'll try to go fundamental on it. And I think for what organizations need to consider, they really need to consider ensuring that all stakeholders have their input into both building and leveraging the value. Because it's been very often where an organization has made an investment that they didn't see the value of overall. So those challenges of understanding the scope, understanding the function, and executing, that's the first big challenge. The next challenge is within the organization itself, how is change managed? How do people adopt this new way of doing things, or this standardized way, may not be new, this standardized way of doing things? And how does the organization retain that capability to continue getting the value? And that's where the people side of the presentation comes in. How do you ensure that people know how to leverage that value of the functions or technologies that you've provided? And is it the right value for them? How do they want to consume the information that the digital twin is providing? And how is that going to change the organization? So challenges are, those things are often not thought out all the way through. And organizations kind of think of things often as, it's a technology we buy, it's a product. We need a high fidelity simulator. Well, what's it going to do? Who's going to use it? What are you going to use it for? And what could you use it for that you haven't considered? Those thought processes or thought journeys really need to, they really need to go across the board from low-level stakeholders to high-level stakeholders to make sure that everybody's on board with the value. So I think the biggest challenge is the change management within the organization and ensuring that the right context is developed before people break ground on building these sorts of architectures, infrastructures, digital twins. And if we talk about lesser challenges and so on, things like technology issues and so on can generally be solved. But if the underlying purpose is not lined up, that's where you're going to have challenges.
Yeah. Yeah, we're seeing that in the market across the board. Absolutely. Yeah. Well, with that, we're at very close to the top of the hour. I don't know if there's any follow-up with this, but we do have a few outstanding questions that we'll make available, and if we can align them with the email addresses, we'll let you guys contact them directly.
Thanks.
Okay, thank you very much for the presentation. I've certainly enjoyed it.
It was nice to have Kevin Finnan and my daughter backing me up.
Yeah. And now you get to address whatever she was asking.
Yeah, she had better answers than I did.
Wonderful. And thank everybody. I want to thank everybody for attending. Certainly stick around, attend the rest of the forum, and hopefully next year we'll get to do this in person. Thank you very much.
Thank you very much, Mark. Thanks, everyone. And thanks to the ARC. This was great. I really appreciate it.
Very good.
Very good, Eugene.
Thanks, everyone.